How are you guys? Welcome back to my channel. We'll be looking at Bernoulli's theorem. This is fluid N6. Okay guys, do not forget to subscribe to my YouTube channel and like and comment that so that when you subscribe you'll help me to grow this channel. Okay, let's focus on this Bernoulli's theorem. You have to know this theorem by head. You must state it. All of the definition that I'm writing down, you should know them by head, right? Bernoulli's theorem. Bernoulli's theorem states that the total energy, I have to know, we must see this, the total energy, it's a keyword, you must know that, states that the total energy of each particle of body, of fluid, is the same, provided that no energy, this is important, no energy enters or leaves the system at any specific point or at any point. We call this Bernoulli's theorem. Bernoulli's theorem. And we must understand that we have three forms. We have three forms of the energy of fluids that regarding Bernoulli's theorem. We have three. We must understand these three forms of energy, and then you must know we have three forms of energy: potential energy, and pressure energy, and velocity and kinetic energy, right? Pressure energy, potential energy, and kinetic energy. I can say like, okay, total energy in the system that we have will be potential energy plus pressure energy plus kinetic energy, right? We have these three types of energy. It's 1, 2, 3 in the system is this energy that we'll have. So you must know that the formula, the Bernoulli's theorem formula, what is important, we must know this. The formula for Bernoulli's is Z1 plus PR1 over PG plus V1 squared over 2G. It's equal to Z2 plus PR2 over PG plus V2 squared over 2G. And then this one, we call it, you can be this is, let's call this 1, you can say this is 2, is 3. This is the energy that we had, but you can recall them in terms of head. Here we have them in terms of head. With this one, we must know that we have this in terms of head, and this one we must write it in terms of head, and this one in terms of head, right? Okay, know this, we call it potential the potential head, which is measured in meters. This one is a potential head, and then this one we can call it a pressure head, and also measured in meters. This one we can call it velocity head, which also this one is measured in meters. It's in meters, right? This we call single, its head. This one is pressure head number one. This one, it's a pressure head, which also we know at the static can be a static head also. Call it a static head. This one, it's a this one is a potential head, which you also call it a static head. It's measured in meter. This one is a pressure head, which is measured in meter. This one, it's a velocity head, which is a kinetic, velocity head measured in meter, which is, we know, it's a kinetic again head measured in meters, right? So you have to know how to apply this formula, right? You must know how to apply this formula. You must know how to apply this formula. Now let's say, how can you apply this formula? Let's say you have a pipe, like this. It might be a tappet pipe or what. Let's say it goes like this. Let's say here we have a register pressure P2, and also here we have a register pressure here P1. Let's see now this diameter. Maybe example I can say maybe this diameter is equal to 80 millimeter, and then there's a rate of flow which is 90 liters per second. Then this diameter, I can say this diameter is equal to 160 millimeter, right? So now let's say I want to calculate pressure. Let's say now this one is pressure 1. Let's say we're given a pressure 1 here. This reads the pressure 1, PR1. Let's say it reads 2 kilopascal, 220 kilopascal. Now we want to know this pressure here, PR2. we want to calculate the register pressure, and then we should neglect, maybe we neglect all the losses or all the friction losses. Let's say friction losses in the system, we ignore the friction losses in the system. So now we know that if it's a water, it's flowing, the system is flowing 9 liters per second. That means throughout Q will be the same. The discharge will be the same throughout. The rate of flow will be the same throughout, right? Fine. So we want to calculate the PR2. It's right. That's good, right? Let's start. What we are given? We are given a rate of flow, and then we are given a diameter. Okay, I can say V here. I can say V1. I can say it's equal to Q divided by area 1, right? We have this, it must be, we should convert this. When you convert this, we divide by 1000. If you divide by 1000, this will be 0.000 would be 0.09 divided by pi over 4 multiply by 0.08 squared. Remember, the diameter is 8 millimeter. You divide by 1000 here. You will, so that will be in meters. Then you multiply. You punch this in a calculator. You should get 17.905 meters per second. This is V1. We have V1. Also here we have a diameter. We are done with this part. Let's check. Here we have this part. We have pressure, we have diameter, we have velocity. 3 things. Here we don't know pressure. We have a diameter. We have also, because the rate of flow is the same throughout, is 90 liters per second. Also here we have a rate of flow. We do the same thing here. We'll come and say V2 should be equal to 0.09 over pi over 4. This diameter is 160, right? This diameter is 160. Then you divide by 1000, you'll get 0.16. Then you square this. Divide by 1000, you square this. When you punch in your calculator, you'll get that this is 4.4763 meters per second, right? We have velocity 2, we have velocity, we have diameter. Now we want PR2. Fine. PR2 we'll get it only if we use Bernoulli's theorem, because now this is the pipe we must use. We have portion A and portion B. So we know that Bernoulli's theorem says that Z1 static head plus PR1 pressure head over, this is density multiplied by G, which is gravity, plus velocity h, which is V1 squared over 2G, right? It's equal to the static head 2 plus P R2 over density multiplied by G plus V2 squared over 2G. This is known as rho density. It might be written as rho. You might find this formula here is not density. Instead of P, they can write it rho. It's the same thing. I mean, P is the same as rho. They can replace P with rho. It's the same thing. Alright, they can replace it here. I can come and say here rho, which is the same thing. It's a density. So static head, we take it a tandem line. The pipe is placed straightly horizontal. Is placed straightly horizontal. If it's placed strictly horizontal, our reference point will be equal to 0. Our static head, because its place is not placed at a certain angle. The pipe is not placed at a certain angle. Rather, it is placed horizontal. If it is placed like horizontal, so our static head will be equal to 0. We consider them as 0. Here we come, static head here. When you substitute, this would be equal to 0, right? This would be plus. We have pressure 1, which is 2, 0 multiplied by 1000. Okay, let me just multiply by 1000 to the power, multiply by 10 to the power 3, which is the same as 1000. Same thing, we divide by density. Let's say now what is flowing here. I can let me say there's water that flowing in the system. If we say there's water, they can tell you once you hear the name there's water flowing in the system, we know that the density of water is always 1000 kg per cubic 1. You understand? Density of water, raw water, is equal to 1000 kilogram per cubic. Right, this is the density. So we substitute here, it will be 1000 multiplied by 9.81 plus we have V1. We have calculated V1, which is 17.905. We square this all over 2 multiplied by 9.81. This will be equal static 2. This one is 0, right? Plus PR2, it's what we are looking for. We don't know. This is 1000 density multiplied by 9.81. This will plus, what is V2? Here is V2, it's 4.476. We square this, we divide by 2 multiplied by 9.81, right? Then you do your maths. If you do your maths, here you can do your maths. You take this, you punch this on your calculator, you punch all of these entities on your calculator. After punching this on your calculator, you take this, you transpose this to the other side, right? You can punch step by step, punch this, you can punch this, and punch this, and punch this on your calculator. You will get that PR2 over 1000 multiplied by 9.81 must be equal to 2.426 plus 16.339. You subtract, you take this to the other side. These are these two, subtract When you transpose that, will be 1,02. Good. And then you multiply, you take this, you multiply it to the other side, will be PR2. You multiply this 1000 times 9,81 into the whole of this thing, into the whole of 2246 plus 16339, subtract 1,02, put the bracket. You punch this on your calculator, you'll get that pressure 2 is equal to 370,27 27 kilopascal. You multiply, I've already converted to kilos, kilopascal. This will be your final answer. This, we call this Bernoulli's, is how we apply Bernoulli's theorem. I hope guys you're fine. Stay alert for the next coming session. Don't forget to subscribe. I will see you when you see me.